Let's see. All right, let's go ahead and talk about. Oh, wait, this is the wrong slides. This is the Doom Turtle deep dive. All right. Just really quickly, because it's summary, we're gonna go over what called abstract classes, interfaces, and enums again. And I know that it was a complicated topic last class, so if you guys have any sort of question, if something doesn't make sense, feel free to just ask about it, and I'll try my best to answer it. Okay? This is when you guys should not be scared to ask a question, because that's the whole purpose of this class. All right. So let's go ahead and talk about abstract classes. Okay, and you guys are probably familiar with subclasses, right? We went over that on, what was it, last Friday? And an abstract class is basically, the idea is you can have a class that says what methods it has, and to an extent you can even declare what that method is. But you can also have any class that decides to extend it, also have its own implementation. So if you remember interfaces and abstracts from last class, you should probably know that the differences between it is that abstract classes can define well, abstract methods and variables, like the child, whatever it's extending the abstract class, it's going to have to implement it itself. But because it's an abstract class, you can also put in your own definitions. So there's like abstract parent, or like here in abstract parent, we have we're able to say go, right? And also because it's abstract and the word is there, you can't directly make an instance of it because it's abstract, but you need to make an instance of the child, okay? And the interfaces are very similar in that they all have a name. You can have, but member variables always have to be final in your interface, and you can only describe what methods it can, and what methods it can have instead of what the methods actually do. And interfaces are not going to have an constructor either. Right, so you can see this is like a really bare bone version of the abstract class, right? We're literally only stating the return type, the parameters, and the name of the methods in the interface, okay? And when you actually extend it, you have to implement all three of them and use it by the keyword implements. Okay, so just to keep it clear, when you're in an abstract class, if you want to make an abstract method, like a method where you only say the name and the parameter, just go ahead and put the abstract keyword in front of it, and then this will become an abstract method, same with the class name. But with an interface, all you have to do is the moment you say interface instead of class, everything in here will need to be implemented, okay? And again, when you use them, when you don't, it's all based on like convention and whatnot, but yeah. So does that make sense to everybody? Oh, actually, let's go over enums really quickly. And you guys probably know about, did we go over this last class? Okay, we didn't go over enums actually. So we're fine about that. All right. Does this make sense to everybody? If this makes sense, can you do the yes in Zoom? If this doesn't make sense, just ask. Brandon and Marco, does this make sense to you? I got yes from Marco. I was going to assume, yeah, Brendan's good as well. All right. And then let's see. Someone also asked about methods, switch, recursion, scope, and array list. Okay, so a lot of things. Let's go take a look. Let's go to the first one, methods. All right. And I guess this is a good time to really try to hammer in, y'all, how we can do methods. Okay. So if you guys remember methods, can someone try to give me like a really basic definition of what a method is? function, right? Okay. Okay. Yeah, and what does a function do? Like what about does a method do? Right. When you call it, it'll do a series of actions. So um, a method basically holds code, and the code will do something based on, well, when the function is called or the method is called. Okay. And then, so this is a static method, right? So static method means that you don't need to instantiate to use it. You can just directly use it out the box. And basically, you can see here that every method has a name, right? Don't forget, and has a parameter. Every parameter you need to define the variable type. And yeah, exactly what Brandon said. This method here will take in a variable. In this case, it's a variable that has a type of int, and we assign it to the name number. And then we return an output using the return keyword, and then we return an int because the method was described as an int. Okay. And then you call the methods by just saying the name of the method, parentheses, and then whatever parameters you have defined. A method may or may not have parameters. In this case, we do have a method that has a parameter, but other times you might not. It might just be a method that does nothing and returns nothing. So you might just have the return type set to void, and the parameters just parentheses. Okay. Does that make sense to everybody? All right, cool. All right, let me see. Let's go over switches, right? So conditionals. All right. Um, how um how familiar are you guys all with if statements? Can you guys give me like the 1 to 10 in chat about how familiar you are with them? Okay. All right, it seems like you guys are all very confident on what an if statement is. All right, then let's go. I'm gonna go over something that I think I glossed over when I taught the class the first time. So I'm gonna talk a little bit about the ternary operator as well as the switch statement. Okay. And the ternary operator is something that is, in my opinion, actually pretty useful because if you use them properly, you can reduce a lot of clutter in your code. And the idea is that it's a shorthand if statement and is really useful when you're doing variable assignment. Okay. For example, here I have a ternary operator. Okay, and you can see this image, right? A ternary operator can be broken into 3 parts. Oh, sorry, excuse me. Okay, so you have the condition, right? And then you have a question mark, an expression, colon, and another expression. And the idea is if the condition is true, then expression 1 will be assigned. But if the condition is false, then expression 2 will be will be uh, will be assigned. So in this line, we're trying to assign a value to string C, right? And instead of directly assigning a value, we're assigning a ternary operator. So the idea is, if, for example, for example, 6 is greater than 5, right? 6 is greater than 5 is a true statement. So because this condition is now true, we're going to go to the first expression, which is this string 6 is greater than 5, and now string C will have a value equivalent to 6 is greater than 5. But if we put in like 4 is greater than 5, right? Just imagine the 6 was replaced with a 4. That condition is now false. So the second expression is going to be used to assign for C. And just to kind of show you guys how this might help clear it up, I'm going to share my IntelliJ. Okay. Just to kind of show you what a ternary operator is expanded. So if we have a string C, right, let me zoom in, and we have a ternary operator, and I'm just going to say if string C is equal to 6 is greater than 5, expression 1 is true. Conditional is true, and then conditional is false. And I also forgot to make this a question mark. Okay, so now we have defined a ternary operator and we're assigning to value C. And at the end of the code, I'm just gonna go ahead and print out the value of C. So right now, what do you guys think system.out.println line? Oh, what is this code going to print out? Can someone answer in the chat? Right, exactly. Conditional is true. And what if I were to put 5 is greater than 5? What do you guys think it will be? Very good. All right. And just to show you guys what this piece of code here is expanded, it's like this. I declare my variable, but I don't initialize it. I put an if statement, and I say, this is my conditional. And if it's true, C is equal to conditional true. Otherwise, else, C is equal to conditional is false. So you can see how even though what we're trying to do here is very simple, we're able to compact 6 lines into one single line. So you can see how that might be useful, right? And then, in fact, now technically there is a way you can make this if statement even more compact. I'll just go over it really quickly. If you're talking about a single line if else statement where you're not going to be doing more than one block, you can forego the brackets and just directly have the statement after the if statement or one line after. But that also means you can't have 2 lines with the if statement. But this is a small little trick. But that's a ternary operator. So just to make sure that you guys all know that, it's a fun little tool that you can try to use. And then we're going to talk about switches. Okay, so switches are fundamentally just, again, another simplified form of an if statement. Okay, and these 2 blocks of code here to the left and the right have the exact same functionality. Okay, and usually the reason why you use a switch is number 1, you're dealing with good primitive types. Number 2, you're working with constants or enums. Number 3, if it makes more sense to have a switch. A switch is really useful when the condition is very simple to understand. For example, this number is 2, or this string will always have a value of info or error or something like that. When the logic is very clear and straightforward, but you just have to do a lot of things based on that, that's when a switch is usually used over a traditional if statement like this. Okay, so I'm just going to slowly go over the syntax of a switch statement with you guys all just to make sure you guys know how to write it. And then I'm gonna go ahead and define a few constants, okay? I'm gonna say, let's see. So CONS, wait, no, am I talking about? No, okay, final, let's do an integer. Let's do integers. And we're gonna say, I don't know, classroom. The science classroom is always gonna have a room number of 1, okay? And the physics classroom will have an integer of 2, 3, and then let's put in English classroom at 3. Okay, I'm gonna go ahead. I'm gonna make a static method, right? That says what class basically, and you're going to pass in which classroom, the room number, the ID number of your classroom, and it'll tell you what classroom you're in. Okay, so right after that, we're gonna go and call science classroom, science underscore classroom. Okay, and I have to make this static as well. Okay, so is everyone following what this example is doing so far? Yes or no? Okay, all right. Looks like most of you guys are able to follow. Okay. All right, so now I'm gonna incorporate a switch statement. We could use an if statement. We can say if ID is equal to 1, then we can say system.out.println science classroom, and then we can do another else if it equals 2, so on, another one, and then blah 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 blah. But that sometimes can start to look pretty colored. So you can go and use the switch statement. So you type in the word switch, okay, and then like an if statement, you put in parentheses, and then you want to put in the variable that you are testing. In this case, the variable we are testing is a parameter, ID, right? We'll put an ID, and then now do curly brackets, okay? So far looking a lot like a for if statement, except you don't put a conditional in, and then you have a switch instead of if. Now, in order to write in your clauses, okay, you're gonna put in the word case, and then whatever value the ID will equal, and then break, okay? And do this over and over again for every single case you have. And then in order to fulfill the else statement, like you know how an if statement has an else statement when all else fails, put in the word default. And then now, whenever ID is equal to 1, in a case where ID is 1, then you can just say this block of code will be called. And I know it's counterintuitive that we're using a colon here, but I know it's counterintuitive we're using a colon instead of a normal like curly brackets like we usually do, but just take it for granted. This is multiple lines. Okay, and you can say science classroom, etc., right? And just to know that a switch statement does not necessarily have to take an integer. It can take in any of the primitive types, except I think arrays. I don't think it can take in arrays. Oh yeah, thank you, Grady. Yeah, there you go. And in recent versions of Java, they have allowed strings. So let me just show you, okay? You can say, okay, it says science, right? And let's go and change values. Yeah, it's only equality, summary. And then what if we put in a case that doesn't exist, like 4? You can see the default calls will get called, and it says, what class are you in? And you might be wondering what all of these break statements are. And the break statements are important because when one switch gets called, when one case gets called, you have to break out of it in order for it to not be called. So for example, if I don't have any breaks in here whatsoever, science classroom. You can see that all 3 of these got called. It went into case 1 and I was like, oh, okay, we're good then. I'm just gonna keep calling all the way down. Okay, so that's why in general, you're always gonna have a break statement inside your switch statements. You don't want it to cascade downwards. Okay. Does that make sense for everyone who had a question about switches? Good? Yes or no? Any questions in particular? All right. Okay, you guys can keep asking questions for Grady. And then let's see. Someone has also asked about scope. Okay, so the scope of code. And scope is basically, I mean, I don't think you have to worry about scope too much, other than the fact that like try not to have 2 variables have the exact same name.
I think when they're talking about scope, you're probably talking about don't anything, for example, that is declare any variable that or constant that's declared within a method cannot be used outside that method, and any variable or constant that's declared within, say, a for or a while loop cannot be used outside that loop.
Yep, that's right. And there was I think I read a book that described these as blocks. Okay, whenever curly brackets exist in Java, you are creating a new block of code, and that block means any variables and any blocks inside that block can be seen, but things outside of that block cannot see what is inside the block. Okay, and it's kind of like a wall, you know. You can peer inside, or you can peer outside, you can peer in your neighbor, and you can peer outside of your walls, but anything that is walled inside your own walls, you cannot look inside of it. Okay. And then I know someone asked about recursion. We don't use recursion much, but I guess I can go over it just really quickly. The idea is that recursion is you're trying to accomplish something by calling the method itself over and over again, and then the method will know when to stop calling itself by a specific condition. And add until 5 integer. Here we have two examples of iterative versus recursive. Okay, here's iterative on the bottom, right? You just have a normal for loop, and we already know we're going to run 5 times. But here, the method itself doesn't know exactly it's going to run 5 times, except that when the parameter it gets passed in will end up getting, when a parameter passed in becomes less than 5, then when it becomes greater than 5, then it will know to stop. Okay, but the recursion doesn't care about what happens in all the other previous calls. I don't know. Recursion is really hard to explain. I think it's one of the hardest, earliest topics to explain. And yeah, Sabri, you asked about optimization efficiency. Most of the time, recursion is not. Yeah, most of the time recursion is not going to be more efficient than most iterative algorithms, but there are only very specific cases where recursion has become more effective, and more or less it's you use recursion because it is a necessity instead of it is an alternative. Okay, if the recursion becomes do you want to say something, Grady?
You can, once you finish your sentence here about recursion, I would like to jump in and clarify Loic's question about where to define variables.
Okay. I'll really quickly finish what I was saying about recursion then. If you think about deleting a folder full of files and more folders, you look into the folder, you see, are there any more folders? And I go into that folder and I delete everything until there are no more folders, and I go back out. That's a recursive algorithm, and that's something very hard to do with an iterative algorithm. Okay, but otherwise, forget about recursion for now. And Grady, go ahead if you want to answer.
So Loic asked a question about should you just define everything at the highest level in the class so you don't have to worry about scope? And the answer to that is no, because you really want them to be, if you're only going to use something within a certain for loop or within a certain method, you really only want it to be within that method. And the other thing is, when you have, so that it's not accessible, it can't be accidentally used outside, it has to do with just keeping what the variables being used in the smallest place possible so that they can't be used in a different place that they shouldn't be. So you just want to declare them where you need it. If it's going to be used in a bunch of different methods, yeah, declare it at the top of the class. If it's just going to be used in this particular for loop, then you should only declare it in that particular for loop.
Mm-hmm. Yep, totally.
Yeah, and it is about keeping things organized, and it's also about when you have people working together, it's really clear that that variable is only going to be used here if that's where it's declared.
Yep. All right, does that clarify things about scope for everybody? I think Grady did a much better job of explaining that than me. Okay. Yeah, Grady, you went over packages and stuff, right? Or did you not go over that?
Yes, I did on last Friday, I guess. Is that when I taught?
All right. Okay, it's okay. We can go over packages really quickly. And the idea of a package is both a way to identify your own code as unique, separate from other people, other orgs, and we have a package naming convention. And also a way for you to organize your code and section it off, just like how you would organize your folders into different, like, for example, all of your assignments, you organize them into different folders or whatever, and so on, so forth. And all of your code in general are always, your package names are always going to start with something that is very clearly identifies your own, kind of like a package identifier. And traditionally, it follows the role of something like com dot your name, and then com dot your, oh, I actually DM that to somebody. Com dot your name to whatever package, or your name.
Why don't I just share the package layout for the robot code, and I think it might make a lot more sense to people.
Okay, all right, let's go there.
No, I have it up. I can do it.
Yep, you can go ahead and share.
So this is the robot code, which we'll get into more of the logistics of in a few weeks, but you see we have robot 2020, and then we have source, and then main, and then Java, and then we split it down into FRC 2020, which is everything that's 2020 specific, and then we have lib, which is timeless, or not necessarily timeless, but not 2020 specific. So this is going to be more game specific and robot specific, and then this is going to be more can be applied to any game or robot. And then within there we have the subsystems and the looper, which you won't understand right now, and some stuff for auto. And then we also have more stuff for auto. I don't exactly know why. Oh, because that's also more robot specific stuff that's not as, doesn't fall into any of those categories. Anyway, but you can see how we want to divide things up in a logical way. Down in the lib, we have all of these folders that are in different places because they refer to different libraries or they refer to different things.
Yeah, does that sort of clear up package structure for you guys? So you, when you're talking about package names, that's something that you want to do in a good way, because when you have a project as large as robotics gets, and in a real industry, in the real world, having good package management will lead to having a lot more organized code. Okay, so I wish it's pretty darn important. And regarding package modifiers, do you guys want to know more a little bit about package modifiers or whatnot, or do you guys think you're good about that?
Very, to answer Sombert's question. The package modifiers are very significant to robot code. We use them a lot to encapsulate.
Right, okay. Just to go over it really quickly, we have access modifiers. So public means that a variable, a constant, or a method can be accessed anywhere in the project, no matter what package it's in or whatever. Private means that the variable, constant, or method is only accessible within its own class. Basically, it's private. And
this would typically be a variable that's defined not within any method, because those would be within only the scope of the method, but within the scope of the entire class.
Mm-hmm. And then finally, if you omit it, then it's considered package private, which means it's only visible within its own package. And Greedy, I think that's effectively the same thing as protected, right?
No.
No?
Protected is something a little bit different. Protected has to do with, hold on, let me find an example.
Okay.
Protected has to do with when you have a superclass that has hold on. Let me get back to that. You go on, and I'll
Okay.
get back to that.
All right. We'll come back to this when Grady is ready. And I think one more person asked to go over inheritance again, right? And again, inheritance is the idea that you can have another class inherit attributes from another class, and it will enter what is like a superclass and a subclass relationship. Okay, and
Let me
then
do,
you want to talk about this?
no, I'll talk about protected.
Oh, okay. Let's go back to grading.
Well, it's not on the slide. Protected basically means, and it kind of goes with inheritance too. It basically means that it's because you have public, which says it's accessible everywhere, private, which says it's accessible within the class, and package private, which says it's only accessible within the package. What protected does is says it's accessible within the package, and it's also accessible within any subclasses, regardless of whether they're in the package.
Oh, I see. Okay, that makes sense.
Yes, Loic, the packages are all the different folders.
Yep, all right.
So you can kind of think of like you have classes within packages, and you have methods within in classes. The files are the classes, and then and then you have code within methods, I guess.
All right. And then finally, Grady, I think I have to pick up a call. Can you take over inheritance for now?
I can. So hold on. Child extends adult, and adult is declared, and adult was a different class. Well, for child, in a different package. So methods are what are protected. You would never say protected class. So it would just be a method that's protected. And if there was a method within adult that was protected and child was not in the same package as adult, child would still have access to that protected method because it's a subclass of adult. Does that make sense? Okay, cool. And to get back to the inheritance thing here, inheritance is all about ISA and HASA relationships. So we have, so you might have a circle is a shape, and a rectangle is a shape, and a square is a shape. But you could also have another level of polymorphism. A square is also a rectangle. So polymorphism basically means an object that can pass more than one is a test. So it can, and often, like if you have something 3 down on a chain of subclasses, so the car is a vehicle and the Ford is a car, the Ford is also a vehicle. So therefore, that Ford, that is part of polymorphism as well. And then instance of just lets you check to see if it's of a certain instance type, and that will also invoke the chain, because if you said Ford instance of vehicle, that would be true. If you said Ford instance of Ford, that would be true. If you said Ford instance of car, that would be true too. And when I say Ford instance of Ford or car or vehicle, I mean an instance of Ford.
Right. Okay. That's a great explanation. Yeah, a child class can indeed have its own child class.
Yeah, it can go on as long as you need.
Yep.
And a superclass can have multiple subclasses, and those subclasses can have multiple subclasses. So absolutely.
You can always think of it as a family tree. All right. Does anyone have any more questions about all that we've learned in the past month? So the extended string just allows you to make another class without rewriting all the same stuff. Yeah, and then you can add on your own like more specific attributes and whatnot. That's right, Loic. Anyone have any more questions?
There's a question about going over toString.
Right.
And Loic, so extends isn't really about letting you rewrite all the same, not letting you rewrite all the same stuff. It's more about, that would be more like what an interface is about, just laying out the methods. But the superclass is really saying that this is a that, and therefore we can treat it like that. So if we need to do something with all of the shapes, we don't have to say we need to do something with all of the triangles, rectangles, and circles. We can just say all of the shapes, and the triangles, rectangles, and circles know that they're shapes.
Mm-hmm. Yep. And I also want to answer Yash's question about toString. And toString is basically just, for example, I have my point class here, right? And I'm going to just go ahead and reuse it. Okay, so I'm going to say point please review point 4. If I didn't have this toString here, and I try to directly print out the point by itself, system.out.println p, it's going to give me a bunch of, instead of printing out what you expect, X and Y, it's going to print out like the address of the pointer of the class of where it is. Like this doesn't tell us anything. Point at 1D2518991. That doesn't tell us anything. So toString is helpful when you're doing when you're converting, when you're printing out a class, you might want to try to print it out in a reasonable way and print out like some variables that make more sense. And in this case, we're just returning a string and we're just printing out X and Y, okay? And now when we do system.out.println, our own toString class is now called instead of Java's default for all objects. And you can see we get a pretty output here. Okay, so that's what toString is for.
Clarify one thing. So the reason we are able to override toString from the superclass is because there is a superclass. So Samuel could go up next to point and write extends object. Java doesn't make you write extends object because every class is technically at some point in the chain a subclass of object. But that is where that toString method comes from. At override is really a courtesy for the editor and the reader that you are overriding a method from a superclass.
Yep, that's right. All right, anything else? It is 3:43, okay. Does anyone have any more questions? So it's kind of rewriting a method from a superclass, and that's when you would use override. Yeah. So for example, if I don't know, if I wanted to do better point, okay, and it extends point, and let's just say I don't like your, what is this? I need a constructor. Yeah, I need a constructor. Also, you can call super, by the way. Super refers to your superclass. Let's say I don't like points toString method. I don't like this. I will just extend it myself and I'll override toString again another time. And then I can like put in parentheses or something like that, you know. So this is something you can do with this is something you can do with overrides as well. And I just cooked up something. No clue what I did. Okay, right. And if I try to use my better point instead of point, you can see that I'll override it. For robot code, will we need to use Java the AWT util to Java x.swing? That's a very specific question. We do use list. So let me double check which package that's from this. List is from See, this is from java.util. Okay, we will use java.util.
But not java.awt. I don't think we use either of those packages.
And JavaX is a GUI library. So and we're not coding with JavaX in robotics. Oh, I can see here that my toString method was overridden, and now I have a different form because this is a better point. Okay. All right. Any more questions, or are we pretty much good? Are you feeling a little bit better after this class? I hope so. Okay. Well, it seems like no one has any more questions. Is that correct? One more round. Does anyone have any more questions? Otherwise, we don't really have much more to say. One final review on abstract classes. Okay. One final review on abstract class. When I got my, wow, this is an interface. Okay. Abstract class car. So the thing about abstract classes is, remember, you can define and say, okay, you're gonna have to have you can define variables like normal, but when it comes to methods or constructors, I think constructors, right? You can do abstract constructors. Can you not? Never mind. But when it comes to methods, you can define abstract methods, and then, but you can also have just normal methods where you just define it properly, just like a normal superclass. And then whenever something extends car, they're gonna have to create their own versions of these abstract methods defined. Okay, and if I go into forward, and instead of implements, I'll say extends. Okay, and you can see here we've put in our own version of forward, accelerate, horn, headlights, check systems, right? We have our own versions, but then but we can also use foo anywhere we want, right? Like, for example, if I say foo here, you can see I don't have an error because I already defined it in the superclass foo. But otherwise, if I were to, like, one of the required ones I have to write myself is forward, right? If I were to delete forward, you can see that an error shows up, and then it will say that you're gonna have to implement the method. And the reason why you want to use an abstract class is because it's also for your own readability and for reliability of your code. And it's to use an abstract class when you know that you're going to be extending, you're going to be making a lot of subclasses of that one class, but they also all have to share the same behavior and share the same attributes. And that's why you want to use an abstract class, because sometimes they will want to share code, and you can use the abstract class's ability to still write normal functions to your ability, but then also you also want to define the behavior, the description of it. For example, I want all of my cars to be able to go forward. Okay, and that.
And also, the reason it would be an abstract class as opposed to just a regular class would be because you know that you're never going to just create a car that's just a car. You know that it's always going to have to be something more specific.
Right, exactly. That's exactly right. Yep. All right, so that's that answered. All right, guys, any more questions, or you guys are feeling good? All right. Well, it is 3:50 and it's a Friday. Oh. Wait, so abstract classes are for something specific. Yeah, they have a specific use case. Okay. But again, they're a tool. So you'll kind of know when you start doing larger projects, you'll kind of know when you want to use an abstract class. All right, everybody, let's go ahead and I'll let you guys enjoy your weekend. And just so you know, we're actually kind of nearing the end of our robot software curriculum, or not robot software curriculum, Java curriculum. And then you guys can expect news about our robot curriculum in the coming weeks. So yeah, have a good weekend, everybody. Bye-bye. We'll try. We'll try. Even though we don't have an actual robot, we're gonna start looking at tools like simulators and whatnot that we can do it with. All right, bye bye, everybody.